In this video, we're going to introduce you or review the idea of what a perfect square is. In particular, a perfect trinomial square. Before we get into that, I want to bring your attention back to fractions. At some point, you learned that 1/2 and 4/8 are the same number. They're exactly the same number, just have two different representations. Now, 4/8 is usually simplified into 1/2. You get an answer, you add a couple of fractions together, you start simplifying, you're like, hey, 4/8, and it goes down to 1/2. But sometimes it's valuable to go like this and write it out as 4/8. For example, if we have 1/2 plus 1/8 equals, you're like, hey, we need to get a common denominator in order to do that. You're like, oh, times by 4, times by 4. We have just changed that into 4/8, and it allowed us to complete the problem. Similarly, when you have a binomial that gets squared, such as x plus 7, and you square it, you do it the long way, FOIL that guy out if that's how you think about it, and you get x squared plus 7x plus 7x. So you get a 14x and then a 49. And sometimes FOIL reminds folks, hey, you've got this middle term you have to worry about. So most often people will take this guy and turn him into that guy. Well, it's also sometimes handy to write them as perfect squares. So let's do a couple more and make sure we got this pattern. X minus 3 squared should give us x squared, and then there's a negative 3x, negative 6x plus 9. Let's do another one. X minus 11 squared equals, this is going to be x squared minus 22x plus 121. So you start to see the pattern that this guy and that guy times by 2. And then that guy over there is squared. So if I were to write this one, x squared minus 8x plus 16, you could think, what is it? Let's go backwards now and say, what was that guy? Now, in factoring, you're like, okay, what times to 16 and adds to negative 8? And you're like, oh, x minus 4, x minus 4. Or you can see that half of this squared is that guy indeed. And it makes x minus 4 squared. So let's do one more. X squared minus 10x. Now let's do a plus 10x plus 25 equals, and that's going to be x plus 5 squared. So now we come into, we're going to write part of a perfect square. So let's write these guys down here. So these are perfect squares, because we took a binomial and squared it and ended up with these. So these are perfect squares. So I'm going to write a piece of a square, and then we're going to complete it. So x squared plus 12x. Now we're going to change color here and say, okay, what number do I have to put there to make it become a perfect square? Well, because of this number right here, we know what we're trying to make. We're trying to make x plus 6 altogether squared. Now if we multiply this out, we get x squared plus 12x plus, and here's the kicker, plus 36. This number right here has completed this trinomial to make it a perfect square. So we've added that number on there. Let's try one more. X squared minus 6x. Oh, we did that one right up here. Let's pick another one. X squared minus 14x. It's going to be close to that one, but x squared minus 14x. If I were to give you this one and said, okay, you've got to pick some number out of the clear blue sky and add it right over here to make this a perfect square trinomial, what would you pick? And you can see, because of this 14, we know we're trying to make x minus 7. Quantity squared. So that means that guy over there must be a 49. We're taking half of that number and squaring it. That's how we get that. Half of negative 14 is the negative 7. That's what goes in here to make the perfect square. And then we square it. And then this guy is now, ding, a perfect square. Let's do one more. What haven't we used yet? X squared plus 30x. And we wonder, okay, what number can I stick in right there? Well, half of 30 is 15. Squared is 225. So we're going to add 225. And now we could rewrite this entire thing as x plus 15 all together squared. So adding this number on completes this trinomial to make it a perfect square, and then we can write it as a perfect square right there.